Good afternoon, everybody. For everybody who may or may not know me, but I am the guy who says every week, welcome to Packet Pushers. I'm Greg Ferro. I'm the host of the Packet Pushers podcast. I'm also a blogger at Ethereal Mind, and I'm a semi-professional journalist at a number of online websites and magazines, and you've probably seen me participating at a number of events. Today I'm hosting a panel on public and private clouds and the way we put them together and the architecture. And it was about a year ago that I wrote a blog post which Ivan, Mr. Pepuniak, keeps referring me to, where I said the public cloud is approximately like public transport. It's perfect as long as the bus goes exactly where you want to go and it stops where you want to get off. It's bloody marvellous. But if you actually wanted to go from your house to grandma's house, it's not very convenient. And that defines my attitude towards the public cloud. Second rate, and it's for poor people, because you'll be poor after you've used it, right? Once you've bought an Amazon AWS, you'll be right poor afterwards because it costs a fortune. Private clouds, on the other hand, are much like owning your favorite Tesla. It's got exactly the right shape, or whether you want to work around in a swagger wagon, you can have your own choice. You can buy a family sedan, you can buy yourself a nice Tesla, you can make the private cloud fit your model, right? And that's the difference between the public and the private cloud. It's the way that we work. And different companies have got different aspects. And what we're talking about is whether we should be using private cloud or public cloud, which inherently brings in the lovely, delightful discussion of hybrid cloud. Excuse me while I just have a little moment while I giggle to myself. Hybrid cloud, laugh. But we're going to talk about that with our panel. So let's move along the panel from left to right. We've got some from the previous one, but why don't we start?
Okay, well, I mean, that's fine. So what would you like me to do? Introduce I'm still the same person that I was half an hour ago.
Excellent. Huzzah! Right. Nothing's changed then.
Apparently not.
just like most banks.
I am also still the same person I was a half an hour ago, but you guys didn't see me before. I'm Scott Sneddon. I'm a solutions architect at Nuage Networks, which a coworker of mine said we're going to be known as the Federation guys by the end of the day. But federating and sharing state and networks, I think, is really applicable to this hybrid cloud model as well, in that we think that federation or sharing of information and building networks of networks is key to any kind of outsource and in-source service and multi-network or multi-site service. So,
perfect.
Hi, Sackman from Billion.
Hi, this is Anjan Srinivas. I'm Senior Director of Product Management for Nutanix. And I'm a different person from the last 30 minutes because I'm enlightened to be sitting with such a distinguished set of people here. So,
I'm Brent Salisbury, and I am probably smarter from the past 2 hours of conversations with you all. So.
Okay. Well, thanks very much for joining us today. So what I guess probably the first thing to talk about is ask the panel. I'm not sure who to ask, so pipe up when you've got an answer, but does anybody here actually believe in the hybrid cloud? Yep.
I'll take a stab at it. There's no right or wrong. I think it's like a life journey, right? When you're single, you want to be yippee, partying out in the night, you go up to the city, rent out there, you pay like $3,000 for a one-bedroom studio and kind of do what you need to do, and then as you kind of start to grow a family, you go to the suburb, look for the taekwondo class like I do, and the school district, and then you buy a house. So there is this spectrum of do you rent, lease, buy, or all the way from the Uber to kind of owning your Tesla. And I think there is no one size that will fit all, and that's the discussion we are on to, whether private or public. There is an economies of scale that will actually impact the way you do things, the way you do business. And what's right for you may not be right for the next person next door. So I think that's where it all comes down to, and understanding what dictates you're going to get an Uber or you're going to buy your Tesla is the decision that you need to make by evaluating yourself.
Sure. Brent?
So maybe start by defining. Right, so we've got SaaS, we've got platform, you've got infrastructure. So I know in my enterprise we consume a lot of Gmail, right? So that's SaaS. It makes a whole lot of sense to keep that there. And then we've got lots of stuff that's still local. So maybe refine it down. Are we talking infrastructure, elasticity, or?
I wouldn't draw a line. I think that so if I look at the public cloud, I see businesses like Netflix, which are fundamentally unfundable business models. Nobody's going to give Netflix $50 million to go and build a data center, and the business wouldn't exist if AWS wasn't able to host that service. Same with Pinterest, same with Instagram. Those are businesses that were able to use the cloud to their advantage because they're unfundable business models. They can get by with $1 million worth, but if they had to build a $50 million data center, they would not be a real business. And I mean, even Netflix today, the big, hoo-ha in the cloud, exists by the grace of Hollywood. And if Hollywood pulls the funding, Netflix is out of business overnight. So you still can't invest money in a data center because it's got no business model. So a lot of the cloud providers that, those companies that we say are all benefiting from the cloud are actually irregular business models or not something that we can see funded, right?
But they do have business models. I mean, they're just different ones.
They're different ones, but they're not necessarily permanent.
Yep.
Or fundable. They're not going to build, they rely on fungible assets.
Well, they're not fundable from a CapEx perspective, but they're absolutely fundable from an OpEx perspective.
Precisely.
Yeah.
So, that's one spectrum of is everything's in the public cloud. But one of the topics we said earlier was we're talking about businesses who run a marketing campaign and want to burst from the private cloud to the public cloud because they need load. What are the aspects of that? Now, Andy, you said earlier that security and control is really important to you. How do you handle the security in a hybrid cloud model?
Well, I think the first thing you have to do is define what a hybrid cloud is. So I don't really know what a hybrid cloud is, so I think I'm just going to tell you about what I do know, and then we can talk about whether any of them are hybrid clouds or not. Private cloud on-prem is the safest thing to do. It's the one step up from a VMware pod. Everyone kind of knows what it is, except now you've got all the resources instead of just the compute with a nice fat pipe into a storage platform of some kind. Private cloud off-prem is growing really fast, and for those of you who don't work in the enterprise, I can tell you private cloud off-prem is very, very, very attractive because you don't have to build data centers, you don't need CapEx, it's someone else's CapEx that's being used, and you can use that for taking burst load, for example, from inside to outside. Good examples in financial services are things like Monte Carlo and Grid, where a risk event happens and all of a sudden you need 10,000 compute nodes. In the old days you had to have 10,000 compute nodes. Now you can have 2,000 with a contract for 8. So that's an interesting model. Secure single tenant private cloud is where public cloud vendors have either set up dedicated facilities for secure single tenants. Salesforce has done a couple of these recently, and they actually don't provide public internet access to those pods. They provide private access to those. Secure single tenant, in my opinion, will grow really fast. I think people will start looking at how do you take secure single tenant models out into verticals. So, if you're in the insurance vertical or the finance vertical or whatever, SaaS has not necessarily done well in those verticals because of risk, security, and control issues. But if it was run by us for us, then I think it would be a completely different outcome. The final one, private network public cloud, is also kind of an important one. So if you're a user of Salesforce but you do not want to be exposed to hacks or potential data attacks over the public internet, there's no reason why you can't put your own private network in or share a piece of someone else's. Again, we've seen quite a lot of people put fiber into public cloud providers in the last couple of years too. So now the question is, what is a hybrid cloud? So I think a hybrid cloud is either a multi-tenant environment where companies who trust each other can actually essentially elastically grow and shrink alongside each other without worrying. An example of where that would work in financial services would be where there's no persistent data anywhere on the cloud that can get attacked. So Monte Carlo is a good example where that would work quite well. When people say hybrid cloud, they usually mean private going to public. But the problem with that is that all of the dials around risk, security, price, SLAs, and control are completely different between an app that you'll put on an internal private cloud and one that will go on the public cloud. And this is one of the reasons why Azure hasn't been very successful, because Microsoft has tried to push everybody to put their data into the public cloud. And only recently, through Fujitsu and others to be announced in the next week or two, are offering real on-prem Azure. And there's thousands of .NET apps and thousands of .NET developers that would like to move to Azure, but they haven't really been able to because you can't set those dials in the right place. And again, the bursting model with Azure is also very attractive, even within your own enterprise. If you have 2,000 .NET apps, and you say, okay, well, I'm going to give this guy 3 virtual CPUs, I'm going to give him this, but actually if he needs more, he can have it, right? So just being able to run that kind of elastic capacity that comes with Azure inside your own environment is very important. So again, I didn't really answer your question, but that's just kind of what I think about it.
This is the challenge I have with hybrid cloud, is that it's not one thing, it's a multifaceted aspect. There's public to public cloud, there's public to private, private to public, and private to private. And there's even, as you say, and then there's even, if you've got two private clouds which are your own between two data centers, which is what some of the orchestration systems are doing, you've still got to bring all those together into a unified policy.
The grid example, we're actually seeing that called community cloud in our vertical. I don't know if other people have heard of that, but community is where people who are in a vertical have decided to go share something.
Yeah, and you apply the same policies and the same standards to the process.
Yeah, the service is defined according to the needs of the security regulations and whatever for that vertical.
So how do we get control of this? So one of the challenges that I have is that when I work on solutions which focus around cloud bursting, which is this idea of transiting data from one cloud to another cloud, data has mass. It's got a certain amount of size. And I actually struggle with getting enough bandwidth. So people have these ideas that moving a 20 gig VM can happen within 5 minutes. Of course, it actually takes more like 10 hours to migrate a machine around. So how do we, I know that Nuage is doing some work in this area with policy and control. How would you get into this area?
Yeah, well, I mean, it starts with connectivity, as you say, and that's connectivity from a bandwidth perspective, but it's also connectivity from a policy and a control and a security perspective. I think the biggest inhibitor that at least in my experience I've seen in seeing people adopt the hybrid model is being able to recreate some of the network topologies and network policies that they have in their private data center in a public cloud. And so that's kind of what we're trying to address is giving you the tools to use a lot of the existing network technology. The other kind of question about hybrid cloud or using public cloud is how I get to it. And even if it's a hosted private cloud, how do I connect to it? Am I buying fiber links to that data center directly from my site? Then it's a pretty simple conversation. I control that end to end and I'm not sharing that resource. But if I'm using public networks or shared networks to get to that data center, even if it is hosted private cloud, there's still a shared aspect to that and a public aspect. And we have models to do that. We have IPsec tunnels and things like that. But
and there's a security guy walking around with an ISO 27001 saying it's all safe. Don't ask me how I got here, but it's safe.
But if it's not orchestrated and it's not dynamic, then it's not cloud. It's tying two data centers with a guy manually provisioning an IPsec tunnel to accommodate that VM move. And then I'm not really taking advantage of all the tools. And so, we really want to be thinking about the orchestration layer as heterogeneous as possible, so that if I want to use private hosted cloud or potentially Amazon, I hate to hearken the great API debate of 2013, but there's validity to those conversations in that maybe I want to use Rackspace on one day and Amazon on another, and my private data center or my private hosted cloud. I need a way to start to orchestrate those together, and the way to do that isn't single vendor. It's never a single vendor solution. We need standards and open tools and open APIs to orchestrate across those.
Sure. Ron, you got any views?
Not that it would add value on this topic, probably. I'll defer.
Yeah, so I think I just was listening to them. What triggered to me was people talk about cloud bursting and being able to run compute directly on the cloud. And you brought up an interesting point. How much ever bandwidth I add, there's nowhere on earth that I can take my enterprise class applications and assume that they will just run there. There is a whole lot of complexity around runbook automation and how do you kind of really restart your network services in sequence to make sure the database comes up first or the DNS came up first or whatever happens. And today I think we are not there yet, number one. I think so that's why when you see a lot of adoption with hybrid clouds or clouds in general, it is being done by the developer IT versus the corporate IT. So it's the shadow IT versus corp IT that's actually leading the charge. So corporate IT is not really leading the charge when you're trying to consume public clouds. That's number one. And even when corporate IT is, they're looking at a low-hanging fruit like archival or DR in order to actually make that business case for them work. Then they can get past around some of the security, because a lot of this data is maybe useless to a security audit when you're putting old log files or old snapshots or any of those things back in an archival tier, where Glacier can provide you like this low cost storage tier which you will never be able to kind of make or build in-house. So some of those things, I think there are clear business values to be added. But when you start to really talk about bursting compute and running them on the fly in public cloud, I think we are still on a very early journey that will kind of take us many years before we get there.
I think there are answers coming in this area. So provided, if you look at projects like Docker and Core, where they actually run application containers and migrate the code from location to location, not the VM.
Right.
So we've got to get away from this legacy model of the atomic unit is the virtual machine, the operating system. Sure. We've actually got to say actually the atomic unit is the code. And if I had two versions of the code and all I'm doing is syncing the database between the two, then I can actually do hybrid cloud bursting. However, that raises the question of security. How do I provide, so in my private data center, which is physically secured, known, all my backups go to a known archival unit which sits inside of the physical boundary of and is covered by my insurance policies without any change, and the costs are known. And then all of a sudden I move that in, I move the database, make a copy of it in the cloud, and how do I secure that? So, have anybody got a view on security in the public cloud? Is it working? Is it happening?
Well, I deal with some HIPAA, so just out the gate. If they won't sign on the dotted line, it's out. Microsoft is pretty much the biggest one that's doing that so far. It's almost what is cloud networking? It's like, I think I went back and looked at a post from like 2 years ago, and it was like, as far as I can tell, cloud networking is tunnels. Right? So it's the exact same thing we're doing in the data center, and now we're just abstracting this kind of problematic network in between that's inflexible and out of our administrative control and crossing administrative boundaries. The bandwidth alone. Are you going to put your workload? Are you going to trust your workloads to 1 or 10 or 20 carriers that workload's going to go between?
Yeah.
Go have fun. It's the same problem, but even worse because you can't even get on that kit to troubleshoot.
Yeah.
I think though that the idea that you can package centrally, regardless of what unit you deploy with, and deploy anywhere is extraordinarily attractive. So if I take an example like Sandy, since we're in October again, and Irene the year before, right? It's quite feasible, in my opinion, to have a weather event that hits the entire East Coast. Most people have 60-mile radius peer-to-peer DR because of SRDF, right? And maybe they don't have that across the board, but they have a lot of that. My take is that the more you can move to a standard packaging and a central repository that has all of your applications in it and the ability to deploy into any execution venue, that buys you a huge amount of flexibility. And I can tell you, having recovered an entire company after 9/11 in 6 days, right, and having done, last year pulled 3 all-nighters for the first time in 8 years. It hurts, by the way. It turned out that not many people actually understand how DNS works anymore. That's one of the other learnings from last year. But the way I think about it is the more flexibility you have around how you recover, the better off you are. And maybe this will turn into the vehicle through which this gets introduced, because when we built Dev as a Service and we were like, wow, we can move our entire dev workload from Weehawken to Virginia by clicking one button. How cool is that? Because we could move anywhere. And after 9/11, one of our biggest challenges honestly was just getting all the code back up, recompiled, relinked, and back onto the execute. We built 7,500 machines in a week. Right, so these use cases, I think you can get somewhere with.
I think DR, going to a hot model of DR is like the training wheels for moving to the cloud, because now you're setting up your applications to be mobile. You know how your workload's going to react. And you're going to save money from your DR provider, because we all know that. It's just.
I like the idea of kind of building on your idea about the data, though. If you're going to go into Glacier or something like that, and now your backup data is there, why not be able to reinstantiate the backup data straight into a provisioned infrastructure? That's kind of interesting, I think.
And also there is a reverse trend, though. I think there is a competing force that's kind of pushing everything back again into private cloud as well, right? If you look at OpenStack, the whole fundamental tenet of OpenStack is to take an Amazon-like infrastructure and build it in-house, and to be able to manage and orchestrate that. So I think it will be interesting over the next 3 to 5 years to see these forces compete against each other and build products that actually try to outdo, because there was a recent last week visit to a customer, and I was asking, what do you worry about most? And they're about losing control. Sure. And then where are you losing control to? Is it to your users? They're like, yes, in a way, but it's more to Amazon. So it's almost the internal IT is competing with Amazon.
Well, how much of it's the human? So I think public cloud exists for enterprise because of the human factor, right? The more times the network guy, the systems guy, the application dev guy says no, the more times that 3 or 4 or 5, 6 times cost to go to the public cloud just goes away, because I can either wait on it to never execute, or miss deadline after
Convenience
deadline.
also has a cost, doesn't it?
Exactly. I mean, that the numbers start being irrelevant when the CIO's job is on the line.
Yeah. When the MD rings up and says that marketing campaign has to shit tonight,
Yep.
and somebody says, I'll get a credit card and put it on AWS.
Well, I think you're seeing a shift from even the HPs of the world that have built out their own public cloud to going, becoming the arms dealer of the local.
Totally.
Like, if you want VM, you want the gold, great. If you want OpenStack for
and
test
we'll support
dev,
it.
great.
We'll support it on Amazon for you. There's a whole support infrastructure opportunity for them too. And I also think, to your point, I think you assumed that I meant public cloud. I don't necessarily mean public cloud. I think private cloud, once it's properly liquid, once there is real liquidity in that market, will be as important to market as public. And one of the reasons why, I think, is a lot of public cloud is quite hard to use. It requires you to have written your app in a certain way or whatever, and whereas a lot of the private clouds are designed to be easy to use because they support out of the box the notions and the wrapping that you've already done around your apps. So
when you're talking about enterprise, right, 500 applications that may be used once a month, but when it's used once a month as opposed to a web provider that's 3 applications that have to be available.
Somebody like Pinterest could designs this thing from the ground up with Node.js, which can scale infinitely on a dynamic number of nodes.
Exactly.
Right? But I'm still stuck with some app that was written 30 years ago on a mainframe that
Cobol
just works.
70.
Yeah.
Nothing wrong with Cobol 70.
No, absolutely not. Now that it's got JavaScript, it's even better these days. And I think the other thing I think seeing happening is that this idea of public to private is dependent on the fact that, and there's a lot of boosters for this, which says everything will be public. And I fail to perceive that to be truth. I think the public cloud today is establishing itself, and it will always exist in the same way that radio and television will always exist in one way or the other. But as you said, the tools for private clouds are starting to come together where we can actually build a cloud orchestration system that is as good as the public clouds, the VCHS from VMware, these other cloud providers are using tool chains of their own, whether it's some of the other vendors. And then if we can bring those tools into the private cloud, you may never need to be hybrid. It's just a case of having your own resources.
Well, I think hybrid in that example will be private to private in a lot of cases, because that way you can not have to change the dial on risk and security.
Indeed.
And still take advantage of the capability,
Yeah, and I think one of the things that I've found challenging in many ways is that raising a purchase order for an indeterminate amount.
Sure.
Right? So, how much will your marketing hosting cost? Is it $10,000? Well, if you have a good one, suddenly it's $30,000, and then the marketing project is sitting saying, well, I didn't budget $30,000.
I have a really good example, actually. I'm advising a big data company, and we went in with a model which was you pay by the terabyte by the month. And the pushback was basically from everyone, we need to know how much it's going to cost. We're like, fine, we'll do small, medium, and large then. And small, medium, and large sells, and per terabyte per month, where they can actually control the dial. Not interested, which is kind of an interesting learning.
It's one of the failures of ITIL is that it always specifies that you must know the cost of something to be able to measure the ROI.
Exactly.
Right? And of course, cloud says there is no fixed cost. It's variable. It depends on what you use. So you say, how much are you going to use? And they say, well, I don't know. So you have to raise, so you end up with a tautology, a lock between the race condition, and there's no way out of it. So everybody gives up and just goes and puts it in their private cloud. 9 times out of 10. Happened to me anyway.
No, I'm with you.
Yeah. So I want to come back to the...
one point I wanted to bring up though is wherever there are mission critical applications that have a performance tied to it, I think it is still really very inflexible today to kind of be able to do that in a bubble. So I think performance is a key metric that will continue to play a role along with other considerations.
I agree.
Yeah, we've heard stories where various of the public clouds are starting to struggle with performance.
Yeah.
They're not able to keep executing according to the timeframes.
Yeah, they're not designed, so they were never really designed with that intent in mind. And a lot of these newer applications have a lot of performance ask from an infrastructure. So if you look at even the block storage from Amazon, it was an afterthought. It was never really built with block storage in mind. And now they had to kind of introduce that later to just accommodate some of the applications moving from private to public. So I think the key to success of why you see public clouds getting adoption is when you remove friction. And I think you brought out the easy word somewhere in your sentence. It's all about ease of doing business, and whoever turns out to be the easiest to do business will win eventually.
Your point just now, though, about storage is really important. One of the things we loved about Viper when we were in the early adopter program was you could essentially expose your file system to Amazon one day, and the same day you could say, oh, I'm going to open that up now to Azure. Right?
Yep.
And that's really powerful. So I mean, the idea that you've got this abstraction around not only block, file, and object, but also around which adapter you're exposing it to, and it's the same data, now you can just remount your Oracle database, and that's kind of a big deal, I think.
Yes, and on top of that, add business analytics on top of it, where it tells you this adapter is going to cost you this much.
Sure.
That one is going to cost you this much. You know, go through a workflow to get your CIO to approve and then press click.
Well, and again, it's not just cost, it is also risk and security. So
Exactly.
when you look at the adapters, the question is, what level of encryption do they support for data in motion coming from the database to the app? I mean, that's one of the key questions.
Absolutely.
So one of the things that I see, so I know you keep on going on about the concept of software-defined storage, which is interesting, but software-defined storage needs software-defined networking to enable that. So instead of using the storage engine to provide the data encryption, you should be using the network to provide the data encryption, because it's a more universal, and you'll also then
No,
get...
I don't agree with that at all. I think data at rest needs to be secured by the storage system, and data in motion probably needs to be secured by the SDN. But there may be occurrences where software-defined security is a better way of doing that than software-defined networking. And honestly, I don't think the line's that clear right now between SDN and software-defined security. But I mean, we certainly have use cases where it would be very handy to be able to create an SDN with a closed user group of IPs and ensure that all the traffic was encrypted. And if that were available out of the box today, yeah, don't tell me you've already got it. But if but if that were available out of the box today, then the whole notion of zones inside your network and how you manage those would be managed totally differently than, you know, Cisco routers with, you know, encryption turned on at the router layer across the entire network. So I'm with you. I just think you have to have both.
Yeah, I mean, at this stage, both, you know, SDS and SDN are prototypical. We're starting out as prototypes, and we're doing early stage deployments, and some of the maturity around those. And it won't be long before the security people come down with their PKI administration systems and spoil all the fun, you know, and wail on about certificate management and all sorts, and prevent all the good stuff from actually happening, I'm sure.
You're making me twitch.
Yeah, they'll make it impossible to
I'm having a Baltimore 4-week outage twitch right now.
On that point, one thing that we've kind of run across with a current project that we're working is, and there was a question earlier about kind of matching the performance of CPUs versus network bandwidth, and you find cross optimization there. In the satellite network that we're currently deploying, we're finding that our performance bottleneck is actually I/O, and and it may be a lack of database expertise on our part, but one use case where we all are of the opinion that storage level encryption is not a good solution is for database, just because of the I/O and the read writes and the performance hit that you take there. I don't know. That's just one consideration on the previous topic.
One thing I would tell you there is having done a lot of work with Oracle on database as a service and Exadata specifically as a platform, what I would tell you is the way Exadata does encryption is like magic. I mean, it's and compression actually as well. I mean, because they control the whole stack, they're able to do things that others can't. And if you haven't looked at it just to see what they can do, it's quite impressive. I mean, compression of 50 to 1 is impressive from where I'm sitting.
I'm going to take you to task there, because earlier you picked up on the commodity networking spiel. You said, I would like to have all my network to be white box and commodity. But then you say with your Exadata you want the integrated stack.
Well, I think the challenge with a legacy application like Oracle, which I've already defined as one that works, is that in some cases, just like with IBM and DB2 and VM as well, the vendor that actually understands the entire stack is in a much better position to provide the efficiency and economy of scale than you trying to build your own commodity approach. And the other thing is there's a massive cost to the integration risk. You know, roughly half the distributed systems in most enterprises I've worked in run databases. And out of those, probably 70 or 80% of them are running Oracle. So I look at that and I'm like, do I want to own the entire system integration risk here, or do I want someone else to own it? Because that's quite a high cost too.
Well,
so I think there's a trade-off, and as a leader, you've got to be able to say, I believe in everything open,
Yep.
But if something proprietary is
Integrated-
better,
the integrated
then
commodity model,
you've got
I
to be
mean-
open to that, I think.
Yeah,
Although Oracle Exadata is still running on commodity hardware.
Yeah, it's still just InfiniBand
So it's just
and-
packaging is in a
yeah, but I mean, we're seeing that too, right? So there's two ends to this spectrum that I see. If you go to the spectrum of the iPhone, where everything's fully integrated, software, hardware, they do the whole thing, and you get a very integrated, very reliable package, but comes with a price tag. And the other end of the commodity hardware is what Intel's
It
done.
did before today.
Yeah. Who knows what's going to go happen tomorrow?
$99.
And if you look at the other end, which is Linux on x86 platforms, which is the ultimate in commodity, and we get the benefits of that. And I believe that ultimately we're looking at probably whether networking will go towards the iPhone model, where the integrated stack with the end-to-end guarantees is what you're looking for, or whether there's going to be the commodity model, which is x86 with some sort of decoupled control plane. Hasn't played out. We haven't proven that either works. Up until now, we've only had one choice, which is integrated stack. Each device is integrated loosely coupled with its neighbors.
Yeah, but don't underestimate how much integration work is done between the Red Hat development community and the x86 platform vendors. It's a huge amount of work. I mean, and it's just like with Microsoft as well. So I mean, you know, I think when you're buying almost an appliance, then the vendor is even more on the hook in terms of making sure that the integration works well. And when something goes wrong, like it always does in version 1 of those products, then there's a huge hoo-ha about, you know, well, it wasn't done properly, or it's the I/O in, you know, Azure version 1 or whatever it is. So I think you have to kind of look at the Red Hat model and say, yeah, the Red Hat model is much cheaper from an OS perspective because, you know, you're not essentially selling the OS itself at a very high price, which Microsoft's doing, but you still got all the integration costs.
Exactly, and you're still bearing it yourself. I mean, white box networking kit, you're still on the hook to test and validate that.
Yeah.
If you're deploying your own OEM gear at scale, you need to do your own testing and validation.
I agree, but I don't think people will do that. It's my belief that companies that are moving into the service business that used to be 100% product companies are going to go, if I do that, I'm going to have a 25% better price on my networking inside my cloud than Joe Blow down the street, and I think that will help me sell my service proposition. Right. So I think that's the way it's going to happen.
Well, and there's a lot of technology we can somewhat fall back on in that white box networking model because you know there have been these levels of abstraction and networking for a long time where we designed layer 3 routing protocols because the underlying layer 2 fabric might not have been as reliable as it could be, and so we've got some separation of functions there that can tolerate a certain amount of failure in some cases, where that vertically integrated Exadata Oracle database thing has been designed for that, and Oracle's done a great job of figuring out that failure and managing that, and it's difficult for an enterprise or even a service provider to go under the covers of that and change that. So
I think one of the messages that is coming across to me as a networking professional, because I'm mostly focused on the network, is that most customers don't feel they're getting fair value for the price they pay for their networking kit. Right, and that's a message that I think is consistent.
I'm not sure that's true. I mean, that may be true, but the way I think about it is that the sale is often happening 2 levels of abstraction away from the network. So if I buy Dell's modular data center, or I buy I/O, or I buy Exadata or whatever, I don't get to talk to Oracle about what networking they put in their rack. And so when you think about it in the old days, well, that was all distributed servers, I had my own switches, I had, you know, all of that conversation doesn't even happen.
Yeah.
So I think it's kind of, you know, it's that the model that has existed around, you know, switch ports and switches and servers is changing, and you can actually watch it change. I think.
But just look at the margins. I mean, the margins are the facts, and they're totally disproportional, and those are going to deflate, just as they did with x86, right? P-series to x86 drove down margins, so it's not going to. I mean, the value is going to be in the service. I mean, you hit on kind of this monetization of the network application, and I don't know anybody that's making a good solid call on that. I think we do have examples if you look at, like, again, back to Amazon, because they are public cloud, buying services as they come on, right? So availability, I mean, because Amazon's going to continue to keep driving to zero, and eventually somebody like Google's going to help them get there a little bit quicker.
Yeah.
And
Well,
it's gonna
I
have
think
to
the other
be a
thing too is a lot of people mistake connectivity for network services, right? In reality, most networking engineers don't spend their lives lighting up switch ports and connecting them to servers. They spend 85% of their time in firewalls, IPSs, load balancers, web proxies, right?
I agree.
That's the hardware that is in danger.
Yeah.
I mean,
That's the stuff that's going to be
because what's in it today?
Yeah.
It's a bunch of x86 cores sitting in a right?
Yeah, that's right.
Wrapped up in a firewall.
But, you move into a software-defined data center where you segment each application. And so the model that I've been promoting more recently is that today we buy $1 million router at the front end with a big fat pipe that goes out to a WAN connection and internet connection. I can change that model and turn that one big router into 50 smaller ones and segment my data loads. And now I don't actually need the big router, and now my expenditure, my capital expenditure, lines up with my ROI. So for every time I deploy a new VM, I apply a router or a firewall with it, and then it scales linearly as I do the cost. In the same way that you buy one server, you get one more server's worth of value. You buy 10 more servers, you get 10 more, performance.
But your assumption there, though, is that I'm going to continue to pay capex to buy that stuff, and I don't think I am. I think.
Well, but it does turn into a consumption model at that point.
It is.
Right?
That's the point.
It's license.
Yeah. It is. It's OPEX.
Yeah.
Yep.
Because, that's the problem with how do we scale the network today? You buy 10 times the bandwidth you're ever going to need for what you think could happen in 5 years, and then you grow into it, and then when you get close to that capacity, you rip that all out and put in another 10 times capacity.
Same applies to storage too, right? So the same problem with storage is that it's I/O bound because of the spinning rust. You can have some excitement about putting some SSDs in front of it to do some better caching, and then developing a new software engine, and then driving a Formula One car around and pretending that everything just got faster. But the reality is that storage is still way behind even networking. It's still back in a 20-year-old model of LUNs.
Yep. Go ahead.
I was just going to say, one thing I wasn't quite following in your previous point, and Greg, it was about the with what you described, taking $1 million router and breaking it up into a bunch of different white boxes. So how do you, in that paradigm, how do you see the WAN links breaking out in that model? Are you talking about sonnet links? You're talking about something different?
Yeah, no. So it's now possible to say, I've got a 10 gig connection going to the internet, but instead of actually just bringing that into one set of routers, one set of firewalls, one set of load balancers, if you define your data center into segments, so you create software-defined virtual data centers within your model and have one router for each, you say, well, this is my VPN, then create a model for that and have so you take 1 gig of data and you feed it into that segment, and that's where your routing and your firewall engines are for that. So instead of having one big router, which is a single failure point, core dependency, and the networking guy is saying, I need another weekend's worth of outages to do the code upgrade, and it affects the entire data center. Now you've got lots of smaller segments across your network.
Yeah, I guess I'm not entirely sure I'm following your line of reasoning on that, but I was just thinking if you're multiplying WAN links, then there's an inherent cost with that also.
Next to that one big one, you just distribute the load.
Okay, so you're talking about virtualizing a single physical WAN link. Okay.
Yeah. Yep. You don't want to run it on hardware, you want to run it on a VM on whatever platform suits your need.
Okay.
Great. Well, thanks. We've just got 2 minutes left, so if we want to take any questions from the audience, now's your chance to throw smarties and tell me I'm an idiot.
2 minutes?
Yeah. Okay, your card, I'll deal with you later.
He's a heckler in the front row.
Yeah, that's right.
We can hear him from here.
Sitting way too close. Anybody got a question? Anybody want to raise a point? Yo. Yep.
And you cover the vast majority of networks. There's now a massive amount of area that you spend your entire life learning one specialization in there. It seems like these two things are at odds. Either we need massive simplification of the infrastructure, we're going to have.
Okay, yeah. So the answer to that question, what you're saying is that technology today is exponentially more complicated than it was 5 years ago, and even more so than 20 years ago. 20 years ago, a sysadmin could know enough networking to make a network and to run a Unix system and a storage engine and make do. But today, the systems are vastly more complicated and requires custom knowledge for each one. The flip side of that is that we now have software to do a lot of that scut work. So my favorite line at the moment comes from Avaya, which is, we are constantly sending humans to do a robot's job. So we go out, a networking guy goes and twiddles with this. A storage goes out there and fiddles with the CLI to make blocks go in hotspots or something equally silly. You know, we need to get away from this idea and take our smart software development tool chains and bring them in to automate a lot of those tasks which are just scut work, and throw them out the door, and then get on to how do I make this storage run faster, and then start to do some proactive analysis. So I think we need to recognize that we don't need to know everything. We need to find automation systems that some are yet to be defined, and this is where the software defined part of any data center comes in, is these tools that take over that work that we do today, which is humans doing a robot's job.
It's actually a big data problem. I think it needs to be solved through big data because there is just no way you can track the data points that are actually being thrown at you in this complex data center world. So it's definitely being solved through big data.
Okay, thanks very much for listening to my panel, and thanks for my panelists for joining me.